how do I build thee? Let me count the ways. This is a relatively new talk for me. I learn something new every time I give this talk, so this is going to be great. And in the middle, if you have a question or something, just raise your hand or something. That's fine. You can interrupt and ask a question if I say something you don't understand or you need me to repeat something. Can you hear me? That is the biggest issue. Okay, good. Good. All right, so let's go through some introductions. I am Melissa McKay. I have been a developer. That is my first, foremost love. That is what I consider my job for over 20 years, all the way from a lowly intern to a principal engineer. And then I started to do some speaking. That's a really difficult thing to do, traveling, if you have family obligations, things like that. Also, if you already have a full-time job and now you're doing research and speaking on the side. So at some point I decided that was a little bit too much. I enjoyed it enough that I wanted to look for a position that included more speaking opportunities, and I became a developer advocate with JFrog. I've been with that company, the cool t-shirt company, so if you ever run into other conferences and JFrog is sponsoring, they are always giving away awesome t-shirts, so make sure you snag one of those. And anyway, when I started, it was right when the pandemic started. So that wasn't planned, of course. So instead of, I think my first travel opportunity was relatively local. I'm based in Denver, and I got sick immediately. So stayed home after that for the next long period of time, started learning a bunch of video editing, online conferencing, that kind of stuff. But one of the pros out of that whole situation is just how much engagement you get with people all over the world at all times. I mean, I could be at home and be in an online conference and be chatting with folks during my presentation. It was pretty amazing. So I did appreciate that, and I hope that we can improve that experience, continue to improve that, because I know it's still difficult for a lot of us to travel, even if there wasn't a virus going around, there's a lot of reasons that people can't travel. I'm a Java champion and also a Docker captain, so I try to keep up with the latest and greatest on these two technologies. Docker especially, I pay attention to what's going on with the OCI, all of the open source stuff around Docker builds, image builds and container builds, things like that. Also an author. This is the book I was talking to a few of you about earlier. This is DevOps Tools for Java Developers. JFrog is a DevOps company. We deal with a lot of the processes, a lot of the tools that are way up around the edges of actually developing your application. So that's a very tiny world that a lot of us live in with our IDE and Java. But there's a lot of other stuff that has to happen to get your software out into production. And one of those mechanisms today we'll talk about is building Docker images. So my introduction to Docker was pretty rocky. How many of you use images today or have at least run Docker build on your machines? Yeah? Okay, awesome. Well, good start. Docker is obviously not the only way to do this, but it's the easiest way, in my opinion, to get started and to learn the basics about images and how they're built, how to launch containers. It's pretty easy if you're working on a Mac or even a Windows machine. You can get Docker Desktop. You can use those tools and get going pretty quickly. My journey, there was a lot to start with. A lot of stuff that I didn't worry about until I ran into problems and was forced to worry about it. So hopefully I can help improve your experience at least. And after this, you're going to have a lot of stuff you're going to want to look up and do some more research on. But rather than get overwhelmed with all of the different options on how to build your images, just what I want you to get most out of this presentation is how to evaluate these solutions that you come across. Just being told how something works is not good enough. You need to know how to look at it, how to analyze it, how to decide what's best for you. So the first thing I did was I went out looking for a project to play with. And I don't know if any of you are familiar with Spring's Pet Clinic application. It's pretty old. It's been out there a long time. but pretty common application. It's open source. I mess with it all the time. There's a lot of different forks. There is a cloud version, so I went and stumbled on that, and I went ahead and started playing with that. And when you do this, when you go out and search, how do I write a Docker file, you're likely going to come across something that looks like this. Now, I love Spring. I've worked with Spring quite a bit. I don't want to pick on them too much. At least, they've got something out here that is easy to use. You can plop it in, copy, paste to get something up and running. But there's a lot of problems with this. We're going to walk through those. I have the link here if you want to look at it. There's more information involved in this Docker file. But it's a very simple one to start with. And we will be making some changes as we go. So whenever you find examples like this, just understand that they are for the purposes of making something simple and consumable, not for putting in your production environments. I think a lot of us have figured that out by now. So going through just a regular build, I don't really expect you to read all this, but this is what it looks like. Pull down the code, you get a bunch of stuff. In this particular build, I went ahead and used my own Docker registry, tagged it with that, and then I updated the deployment for this image, and then I deployed it to a cluster just to try it out on my local machine. And this is what I got, so I was very happy. So step one, just get it running so you have a baseline. Don't start mucking around and changing things until you get something up and running. Then you can start making incremental improvements, okay? Always look for opportunities to improve. This is good enough, it works, but not enough to leave it like this. Lots of things to worry about. Most of the time, we concentrate on performance, on reliability, making sure that our application behaves the way it's supposed to with an appropriate amount of memory and garbage collection. That can get pretty tricky when you're putting Java inside a container. And then we're also worried about build times, making sure that we have decent test coverage to catch any bugs. And I've underlined and bolded dependency management in this list. I hope you all know by now, especially at this conference and all of the talk about security, how important this is to pay attention to. How many of you have been responsible for updating any dependencies because of vulnerabilities? Yeah. Everyone that works with Java should have been doing this. Yes. When you add Docker to your stack, you now have this whole other animal to deal with and a whole other set of issues to think about. And the size of your image is one of those issues. That's something that you're really going to care about later. And one issue that slapped me in the face immediately when I started using Docker was when my team was still on Java 8. I just wrapped it up, put it in an image, put it out there, and immediately got out of memory errors that I didn't quite understand, didn't know what was going on there. And that comes from not understanding the progress in the code bases between how Docker was built and how Java was built. There's a little bit of overlap there. And at one point, early versions of Java 8 didn't fully cooperate with Docker when it came to allocating memory and stuff for containers. So that can be a problem. It's good to understand the history of what you're using. So how many of you are still on Java 8? Yeah, not surprising. Not surprising at all. Something I've found, at least in some of the teams I've been on, it was such a problem to upgrade that people started leaving Java altogether. Like, we're just going to rebuild this in something else. I don't know if you've experienced that, but man, if you can get to 11, 10 is the hardest battle. 9 doesn't really give you anything other than, try to get to 10. Once you get there, very, very easy to keep up with the upgrades. So yeah, highly encourage trying to do that. But I know there's lots of reasons, lots of legitimate reasons that a lot of folks stay on 8. All right, let's talk more about size. Why does size matter when it comes to Docker containers? This isn't something that we worry about too much, other than, especially if you're using Spring. Spring Framework brings everything in. You can get some pretty big applications, but it actually turns out there's some very legitimate reasons to worry about size when you're talking about Docker containers. And one of those reasons is speed. When you think about continuous integration, this is when you start caring about the speed of your builds. So not as a developer, we live in the world where we bring down the code base, we fix things, we change things, we rebuild over and over. So that's one place it matters. It also matters when you're checking your code in and your build server now has to build that code over and over. So we need to pay attention to how our build actually works. And as a developer, this is something you really need to understand fully, is how your build works. How, especially if you're in a multi-module job application, for example. How does each component depend on the other? How can you find ways to shorten that build time? Running tests, concurrently, that kind of stuff can make a huge difference. In the context of Docker images, this doesn't necessarily mean like the startup time of launching a container. When I talk about speed, that's somewhat related. But what I'm really talking about here is how much time it takes to push and pull an image. And it does stand to reason that the bigger an image is, the longer it's going to take to send and receive to a registry or to your production environment. There's some details in caching that make a difference as well. We'll get to that a little bit later. But it's safe to say that smaller images will transmit faster and quicker than larger images. When you want to roll out updates to your services with minimal downtime, this is going to make a big difference, as well as automatic scaling of your services. You want these processes to be as fast as possible. We talked about build times during development, so regenerating and transmitting those large image layers during a build after every commit can really slow down your build processes as well. All right, another one we've heard over and over during this conference is security. It's kind of simplistic to think of it this way, but the less you have in there, the less number of packages and libraries in there that are possibly containing vulnerabilities, the less there is, the less you have to worry about. Make your attack surface as small as possible. Things that can cause you problems by letting an attacker escape the confines of your container, or other risks like leaking private data. These are things that you can help control by mitigating. You can mitigate that by controlling the size and how much you put in there. So reduce that attack surface area. And the last one is money. This is a big one, especially if you're using cloud architecture and you're paying for every bit of storage. This reminds me of, back when, it's going to age me a little bit, but do you remember when you had to pay for every text you sent on the cell phone? It's ridiculous. I hope this gets better, and I hope that paying for storage gets a little bit better. I remember setting up a whole environment in Amazon once, and the fine print there says, your bill might not be exact. Just trust us. It'll be okay. So even trying to figure it out, how much you're actually using and for how long, can get challenging. This is where we're at right now today with cloud storage infrastructure, so we need to deal. Image sizes, though, can really get away with you if you're not paying attention to it. So be mindful up front about everything that you're packing into your images, also your processes. Are you actually storing every single commit in a brand new image every time during your continuous integration? This is something that you'll want to think about and be mindful of. All right, Docker layers. Let's talk about that because that's going to help you manage your sizes. Docker layers correspond to instructions in a Docker file. So in this example, Docker file, there's just only 2 of these instructions will result in an actual layer. You can see with each instruction, we're building more and more into our final image, and that's going to be increasing the size. Take a look at that first line. That first from instruction, that's a parent image. So Docker files, you can build them based on a parent image. Well, that parent image can have another parent image. It's called a base image when you can't go any further, and a Docker file for a base image would have from scratch would be the first element in that Docker file. So given that, it's hard to tell how big this is, right? Unless you start pulling down that parent image, take a look at that too. It can really get out of control fast. This particular one is from the OpenJDK 11 image. We will talk about the differences there in a moment. So how can we analyze it? I just said it can be difficult to learn how big these are, but you want your final production image to only have what's needed for the application to run. You want to get rid of all the extraneous stuff. That base image, it's composed of layers itself, but we may not have the Docker file for that, so how are we going to know what's in there? And there's a few different ways of doing this. The OpenJDK image that we were using is actually an official image in Docker Hub, and this is advantageous because official images are required to be transparent in how they're built. You should be able to go and find the Docker file for those images. In fact, let me show you how to do that. All right, if you were just to search for Docker official images, skip down the docs section and look for this one right here that's in GitHub. These are all stored in GitHub. In this folder, library, if you drill down in here, you see all of these options for official images. Let's pick Alpine. This one's an easy one. So if you click on one of these, this is a file that is going to be consistent across all of those library images. This line right here, you're going to see in each and every one of these. It is another Git repo. And this is where you're going to find more information about that particular image. All right, so let's go to that Git repo and check it out. Some of these are organized a little bit differently. Pay attention to what branch you're on. Sometimes you'll find different versions in different branches. Other times you'll see different versions in different directories. So just kind of, pay attention to how it's organized. Let's take a look at Alpine 3.13. Let's pick one of the supported OSs here, and here we can find a Docker file. If I open up this Docker file, I can see that this is in fact truly a base image. It starts with scratch. Now, some official images, they're not all base images. They might have another image in here, and you'll have to repeat that process again to do the research and find out, exactly what's in there. All right, let's go back. Okay, that can get pretty arduous. There are some other ways we'll talk about on how to analyze some images, but that is one way to have some due diligence in doing some research. One of the things you'll notice right away, and if you're new to Java and new to images, and new to Linux even, if you don't have a strong Linux background, this might be a bunch of mumbo jumbo to you. It was to me in the very beginning when I looked at it. I'm like, what are all these names? What do they mean? When you look for available tags for official images, that can get pretty overwhelming. If you know, maybe you shouldn't be using a full version of OpenJDK, well, what should you use instead? And you have all of these choices. And remember, there's also tags called latest. That is generally expected to be a point of the latest stable release, but the way Docker images are tagged, these are pointers. These can be overridden at any time, so the same name can point to a completely different binary today than it did yesterday. So pay attention to the SHAs of these things when you pull them down, and I would even almost recommend in your Docker files including the SHAs and not just the name of the images themselves. We won't go into that deep, but do your research. So as far as these names go, there's no mystery here once you realize what these names indicate. For a Java application, of course, you can narrow down your choices by Java version. But then if you need to install additional packages on top of this image, you might need to pay attention to the Linux version. These are all these names just stand for different variants of Debian. So moving from one to another is just like a major upgrade, right? Alpine is interesting, and I put some notes here about Alpine. Alpine images are based off of the Alpine Linux project. They produce generally small images for container usage, very popular. You'll see a lot of Alpine usage in a lot of examples on the web. But Alpine isn't really a supported release by OpenJDK, and that comes from their documentation. They're only released for early access OpenJDK version releases, and they're not updated after GA. So once you put one in there and then GA happens, it's not maintained anymore. There's something else about OpenJDK images I'll talk about again later. It'll come up again. Well, I'll talk about it now. So if you were to go to Docker Hub right now and look up an OpenJDK image, it's going to tell you it's deprecated. This is pretty recent. This is another reason why you need to keep on top of your images and what you're using. They now recommend to use, one of the other supported versions, Amazon Corretto, Zulu, one of these others. If you use another vendor for support, it makes sense to use their official images. Okay, whatever you choose to use, once you've settled on a base image, get an idea of how big they are, and you'll notice right away that a JDK image is unsurprisingly bigger than a JRE image. That makes sense, right? Slim images are going to be smaller than the full images, so do your work to optimize these. Make sure that you test well, because you may pull in a slim image and it turns out it's missing something that your application needs. So the best thing to do is have a good test suite. Make sure that your application functions using a smaller image. How to analyze these, some other tools you can use, especially if your image is not an official image and you don't have immediate access. There are other ways that you can dig in there. This is just using Docker history. It gives you, all of the layer information here. There's some more information that you can get in Docker Desktop. I can show you that at the end if you're interested. It's a pretty good interface to be able to look at images that are on your system. Dive is another tool. I use this one a lot. It's an open source tool out there. I stumbled on that application when I was rooting around for another image that I didn't have the Docker file for. And I just wanted to understand what would all be in a container that would be launched from that image without actually launching it to get in there and find what's in there. Dive pulls the image that you specify, and it gives you an interface where you can compare changes between the different layers. Very similar to Docker Desktop, but even more in depth. You can actually navigate to different parts of the system inside a potential container. You can see exactly what's been put in there, what the file structure looks like. This has several layers. Those are indicated in that top left area. For each one of those, you have the size of the layers. You have instructions, how those layers were created. And in this screenshot, we're sitting on that first layer, and it's 124 megabytes. Just moving down to that last layer, you can see, as you move down the layers, you can see differences on the right side of the file structure of a potential container, everything that's been added. That green color is everything that's been added. Yellow is everything that has been modified. And it's a little bit frustrating. You can't, this tool, it's in progress. Pull requests are open, of course. You can't horizontally scroll very easy in that interface, but it certainly served my purpose to figure out where I was getting a bunch of image bloat. One thing that I've seen is in some CI systems, if someone adds something, image is rebuilt, and the size changes dramatically, there's actually a pretty quick check that you can use command line with dive to see that, and you can use that as a quality gate and have an alert sent if the image just suddenly got much bigger than it was before. I thought that was an interesting use case in automation anyway. Okay, this is a screenshot of the Docker desktop dashboard that also has a pretty good visualizer of layers as well. Not all of these items correspond to layers, but you can tell which ones aren't. They would just have 0 bytes in them. But I like this tool because it's definitely more convenient to get the entire command for a layer that you're interested in, how it was built. This one right here I'm sitting on is pretty lengthy, so I like their interface for that. Okay, back to base images. I'm going to really pound on this hard because it does make such a difference. Your base image, if you're not pulling, an official image, where is it coming from? It could be a standard organization platform image that you've been asked to use, but consider if it's from a public repo. Is this open source? Are there licensing considerations to be concerned about? Is it a well-known maintained image? Is it an official Docker image? These are, if it's something that's just off the street, I mean, this is just like pulling in a random dependency that you don't know any of the history, you don't know the authors, you don't know how much it's maintained. So be careful of this. And just because you find something on Docker Hub doesn't mean it's safe to use. Anyone use NPM ever? There's a lot. Anyone can put anything out there. So it's up to you to do the due diligence, do your research, make sure that you understand what you're pulling in. Now that we know we can change our base image, we can try using one of the smaller images. So in this case, I continued to use OpenJDK. Obviously, you're going to want to try to find something else now. But this is a version 11 JRE bullseye image. And it just included the JRE, which made me happy. I assume it's smaller. This is the latest version of bullseye. Like I said before, you probably don't want to use latest. You want to specify an actual tag there, or an actual SHA. I went ahead and rebuilt the same project that I did before. So if you recall, before I built it with the full version of 8 OpenJDK. This one is a JRE version 11. But rather than go back and compare line by line against the previous output that I got, let's use one of our tools just to see the size. I just used Docker Desktop to find the size of these images, and I'm pretty happy with that. 391 megabytes versus 744, which was the original. But that's not enough. It needs to be tested. It needs to go through the whole process. I was also able to run it. We can go pretty crazy here for parent images. There are lots of different choices. You can make your own based off of a Linux distro image. There are distro-less images. Now, these are images that Google has put together. There's a link here to look at those. It's limited availability on what you can get, but they're usually around a programming language. These are the ones for Java. These don't even include a shell. So when a lot of these images, they may have packages in there that you don't need for your application. In the very beginning, we said only put in what you absolutely need for your application to run when it's deployed in production. Why do you need a shell? And there's a few arguments that I've seen people go back and forth on. One is if you don't have a shell, that means you can't even get into a container when it's running, right, to see what's going on in there. Then you have to step back and ask yourself, why would a developer or anyone be logging into a production container anyway? Maybe that's a symptom of bigger problems. It's probably better to set up a system where you have errors or logs or anything from that container being shipped somewhere else to look for them. Anytime you find yourself wanting to exec inside a container to see what's going on in there, that's indicative of a problem that you need to work out. Also, not having a shell, if you can't get in, that means nobody else can get in either. So if you happen to have processes in there that are running as root, you have less likely that someone could break into that container and then have immediate access to stuff that's on the host. Another option, JLink. JLink is bundled with OpenJDK 11. You can make your own custom runtime. So even instead of having everything that comes with the JRE, you could actually figure out the dependencies that your application needs, bundle them together, and only choose those modules to include. And that's also another good way to make your images significantly smaller. Now, one of the assumptions that I made originally when I heard this solution was that, well, that means that your application needs to be modularized. And I know a lot of people moving from Java 8 to Java 11, sometimes you don't want to take that extra step of modularizing the application, so they don't do it. It is a little bit tricky in some cases if you're using libraries that are not part of the JDK, like I don't know, some of the FX libraries that aren't included anymore. That might be something you would want to put in separately. But there are methods to be able to use JLink in those situations. It does not have to be in modules. Those things will just go in the unnamed module. Okay, let's go back to our original Docker file. Look at that. Another layer that we should be concerned about, and it results from that copy instruction. We know that this is a Spring Boot app, and Spring Boot creates fat jars. That is a fat jar that has already been built by some other process before this image is created. So there's two things here that bug me about this type of Docker file. There's a performance problem, or like an efficiency problem. Understanding that Docker layers, the way that they allow us to benefit from Docker's caching mechanism, when a Docker image is rebuilt, if there are no changes detected in a layer, then the cached version of that layer will be used. Well, if you're using a Docker file like this, what happens every time you make one minor change? Everything has to be, that whole line has to be regenerated. That layer has to be regenerated because it's all wrapped up in that fat jar. That means you're busting cache every single time. So you're not taking advantage of any of those, performance mechanisms that Docker's pretty clever in giving you. Maybe it's time to start splitting up that fat jar. Every time your app changes, it's going to slow down your development builds and your CI builds in your CI server. Also, this kind of feels incomplete. Someone looking at this file for the first time, maybe someone new to the project even, they can't immediately intuit where that jar file comes from. We've split up our build into two different pieces, and you have to know the details about the Maven build and complete it before you can build a new container image. So that's just more of an opinion of mine. I like to see all of the build information in one step so that I understand how that is built, and it's no mystery where these things are coming from. So a better example is to break up that fat jar. This is another Docker file. It's dealing with that first efficiency problem we were talking about. Starting with Spring Boot 2.3, the Spring Boot Maven or Gradle plugin will build jars that include layer information in the jar file. And that information organizes and separates out the different parts that you're likely to see change between the builds. A result of that is what you see here. You can see that our dependencies are separated out in different directories from the application contents, and you can extract those from the jar. So look what's happening here, though. instead of just copying the one file, you've got different layers here that you're dealing with. And that first group that contains the dependencies, that's expected to change less often than the last group, which contains class files for code that would be in active development. And how does that benefit us? Well, now when you build your file, when you're making minor changes, it's likely going to be that, one of the later lines, that last copy line, that will need to regenerate a layer. So your builds are going to be a lot faster. If you haven't done this, or if you're doing that old copy method of just copying a jar, that's really good homework assignment, is try it that way, then try breaking it up, and just see how fast your build times change. Anytime you have something that changes often, it needs to go later in the Docker file. Okay, the second complaint that I had, this is the problem about not really knowing where that jar file came from to begin with, because you're stuck with two different steps. You have to build your job application, and then you have to build the Docker file. This part actually includes the build in the Docker file, and this is a multi-stage build. This is obviously a much abbreviated Docker file to fit on the slide, but you see that there are two from instructions here. The first is using full-on OpenJDK because there's also a way to do the build, the second part that produces the artifact, and then the second part is the actual base image that's smaller, the one that we chose to use, and that's the point when we copy the jar in there that we want, the items that we wanted from the build. And that whole first part is not saved, so it just gets trashed, and the resulting image is going to be the smaller image using that base image. But if you're a developer looking at this file, it is very clear how the build works. Okay, we've added build information in the Docker file. That makes it more complete, but we're still stuck with two different things. We're building the job application, and then we're building the image. This project, it already uses Maven, so why can't we just use Maven and just make a change in our POM file and be done? And you can absolutely do that. The Maven and Gradle Docker plugins do just that. Add those with their settings, and you don't have to worry about it. So I tried that, but what was interesting to me right away is what happens to my Docker file. There was nowhere to put in a Docker file by default. So I was curious what was going on there. That was not what I expected. And it turns out that those plugins actually use build packs. Paketo build pack, to be specific. There's really good, I like build packs just for the reason in that it kind of alleviates some of the heavy lifting and having to learn how to write a Docker file. Build packs are maintained by other providers that look for indications in your source of what kind of application it is, can determine if it's a Java application, if it's a Node application, whatever. There's build packs for the different languages. It identifies the type of application and does what it needs to do, all the magic under the covers, to create an image in the end. I don't like magic. I want to know what it's actually doing. Even though it's easy to incorporate, I still want to understand what it's actually doing. So finding out that there are actually 2 images that get downloaded. So once I created this build, and I was using the Maven plugin for this particular build, I went to look at my images to compare the sizes, and there's actually 2 more images that just appeared there. So by requesting this to be built with build packs, these build packs require these images to be downloaded. Well, then I started asking questions. Where are these coming from? Are they coming from Docker Hub? Are they coming from somewhere I don't trust? Do I trust the maintainers of these build packs? So something I would suggest is to set it up such that, and there are settings, this is what you end up doing. You trade your Docker file learning with build pack learning. You're going to be stuck with reading documents no matter what you do. But there are settings where you can customize where these images are coming from. You can create your own. You can relocate them into your own registry so that you control when they're updated, for example. That's a big one, because every time this image is built, maybe you get a new version of a build pack. Maybe that one's broken today, right? So it would be good to have some of those updates under your control so that you're working on your own schedule and not someone else's schedule. It's just one more moving part to protect yourself from. I did size them. You can actually see the 2 extra images there, the Keto build pack images. The sizes were pretty good. By using build packs, I was able to eliminate, several megabytes from my image. The build packs one was 327. So that was interesting. Don't take for granted that one is always better. Always make sure that you're making these checks. Other methods, there's Jib. This one's pretty commonly used with Java. This one has a simple command line to run it. You just include the plugin into your POM file or your Gradle. And the thing about it is it builds and pushes your image for you to a registry immediately, which reduces the number of steps. That bothers me a little bit because I like to see my images on my local machine before I push anything anywhere. I want to do some analysis on them. I want to check for vulnerabilities, things like that, before I check my stuff in, right? Jib, however, the point is being able to create an image without having Docker installed. So if you're in a situation, and maybe this makes more sense for like a build server to build with Jib, or any environment that you can't have Docker running for whatever reason, Jib is one way to do it without Docker. The problem is if you don't have Docker on your machine, you're not going to be able to evaluate your image until it gets pushed to the registry, and then you have to pull it down from the registry, which assumes you have something on your machine anyway in order to analyze that image. So I have mixed feelings about Jib. I like the simplicity, but the whole point of just avoiding Docker, I find it got a little bit annoying to me. So no matter what you do, no matter what you choose, just make sure that you size them up, make sure you evaluate them. Don't assume that you can predict that outcome. Some images from build packs turn out to be bigger than you expect. Always verify those results. So I did that with my Jib build as well, and it turned out that my Jib build was similar in size to the build packs one, or the Maven plugin one in the beginning, or the original one. Sorry, not even the plugin. The original build that we made with the JRE version of OpenJDK. So it didn't beat the build packs method. It didn't beat the Maven and Gradle plugin method. I thought that was interesting. Okay, that is it. I have a couple of other things to share with you, just tools that you can get as a developer to analyze and look at these images a little bit better. But at the very least, go through Docker's Getting Started documentation if you're new to Docker. Get familiar and comfortable with those commands that you'd use in a Docker file. And the basics on how to assemble a Docker file. You've learned a few of those today. Then your next step would be to flex your Java muscles, decide how you're going to include your Java application into your containers. There are some concepts that are explained in the Spring Boot Docker guides. These are topics that are not specific to Spring Boot, so it's definitely worth the read, even if you're not using that framework. The examples are simple enough to follow. We saw the very first one. It's pretty simple, 4-line Docker file. The dive tool, there's a link here for that. Third one down. That one's just here for reference, but it's an interesting tool to play around with. There's a couple of other articles to look at. Oh, something I'll show you in a moment. The OpenJDK documentation on Docker Hub, we'll take a look at that in a moment. Anytime you use something from Docker Hub, make sure you're paying attention to that documentation that they include there. Even if it's an official image, there's a lot of helpful information there. There is a couple more here. That CVO link, the third one down on this screen, this one, if you're new to Kubernetes or you just want to be able to deploy to a little cluster, you need more than what you can get on your local machine. This is a little company that I came across that just was very clear-cut and straightforward on creating a Kubernetes cluster and then being able to interact with it. It's pretty cool. All right, that is it. I promised I would show you a couple more items. First, let's take a look at Docker Hub, at what OpenJDK looks like right now. Here's the nice label, official image label, but you need to go further than that, drill down in, and you'll get more information about this particular image. There's so much out there right now using OpenJDK, so hopefully people are paying attention to this and keeping their stuff updated. One other thing, let's see. Here's another tool. If you have Docker Desktop, you choose to use that. There's actually a extension here that you can install, and you can scan, and you can do a security scan of any image. So let's say you've downloaded an image, you've made some changes to it, or you've built an image from your application, and you just want to check it out, make sure that you haven't done anything horrible before checking in your code. You can use something like this to scan your image, and it'll give you some more information about the existing vulnerabilities or any new ones that you may have unintentionally added. One other thing that is really cool, that same plugin can be used with, now maybe if I can get to it. And get my ID to open. I think it's locked up here. Well, the same plugin can be included in your IDE. What's really cool about that is if you make any changes to your POM file, before you even check those changes in to source control, you can do an analysis of the package that you just added in your job application. That is pretty handy. That way you can just stop those problems before it even gets caught in your build server. All right, any questions? Yeah. Yeah. Uh-huh. Yes. So when if you have your Maven stuff set up in your IDE to constantly grab the dependencies you've asked for, you can modify your POM file, and there's another window that will run in the background. It'll pull down that dependency to your local Maven repo, and then analyze it, and it gives you like a grid explanation of what, if any, problems there are, and what a fixed version could possibly be if there's a later version available, that kind of stuff. And I wish I could show you, but it looks like my IDE has crashed. It is, yeah, absolutely. Yep. Any other questions? There is a whole conversation about that here. I went through looking at this, and I'm not sure. I'm not sure if the community just doesn't want to keep maintaining that when there are so many others out there that are good, if not better. But yeah, if you're curious, definitely take a read. Yeah. But that's part of something I know in the past I've been on teams that have struggled with, the constant need for getting new features or getting bug fixes, that kind of stuff. And there's been some neglect in keeping stuff updated and up to par. And I feel like every development cycle, that should be analyzed. Probably even a complete development cycle that only does updates, because sometimes that can be a troubleshooting nightmare when you update everything at once, just trying to figure out if something broke, what broke it. So managing that is a whole nother issue. All right, anything else? So those of you that are new to Docker, are you going to go and start looking at Docker Desktop? Yeah? Cool. Good deal. Good start. Yeah, they have really good tutorials now as well. I've seen that documentation over time improve dramatically. All right. That's it. Thank you all for coming. Hopefully you can take something away and learn from this and start sizing up your containers.